Yes, students. Like in first exercise, yeah, choose any question from 7 to 10. We'll do it one problem. Any question. Yes.
Sorry.
Question number 8. Okay, right. Here the question number 8 is minimize and maximize. Okay, we have to find the both the values. Okay, for that the objective function is, okay, here the objective function is clearly z is equal to same as it is whatever we have done previously. Here also we'll do the same thing, like z is equal to x plus 2y subject to x plus 2y greater than 100 and 2x minus y lesser than or equal to 0. And they have given three linear inequalities here. So we have to take three equations, like, okay, eighth one. First write that given objective function z is equal to x plus 2y. So what are the constraints they have given, students? Constraints, inequalities. X plus 2y greater than or equal to 100, and the second one is 2x minus y lesser than or equal to 0, and the third 2x plus y is lesser than or equal to 100, 200. Here x greater than or equal to 0, y greater than or equal to 0. So here given constraints are x plus 2y greater than or equal to uh, like then 2x minus y is lesser than or equal to, and 2x plus y lesser than or equal to 200. And non-zero, these are the non-zero restrictions. First, I'm going to take one by one. First, with help of given constraints, we can draw the graph in first quadrant. We are going to get the graph in first quadrant, like feasible region in first quadrant, because x greater than or equal to 0, y greater than or equal to 0. As it is, students, whatever we have done, like here, first I'm going to take x plus 2y is equal to 0, and 2x minus y is equal to 0. And third inequality 2x plus y equal to, I'm taking 200. Okay, right? When I take x is equal to 0, then y is equal to, sorry, this is 10, I think. Yes or no, students? Oh, video off, okay. Can you able to see the screen properly?
Yes, sir.
Yeah, fine. Uh, Simple. Y is equal to 5, and when x is equal to y is equal to 0. Take here y is equal to 0, x value is 10. Here also same, x is equal to 0, y value 0, and y is x is equal to, both will be 0, 0. That's all. It is clearly passing through the origin. So this is not passing through the origin, so that, yeah, x is equal to 0, y value 20. Y is equal to 0, x value 10. Got it? So with help of,
It's 200, sir.
yes, what is it's 200. See here, if you not take 200, we get wrong. This is 100. Fine, students. Now draw the lines. Draw these three lines. Yeah. So what is the maximum value of y? Maximum value of y is 200. X value is 100. X value 100, y value 200. Then on x-axis, the units on x-axis, I am going to take 100 means what are the units will take here? Yes, 20, 40, 60. Then finally here we can take 200. I'm going to take here 200. On x-axis also 20. This point is clearly origin. First, what is the first one? When x0 y value 5, when y0 x value is 10. Identify this point, x is equal to 10, x10 y5, y5 here. Okay, this is 5, this is 10. You can draw the line which is passing through these 2 points. Yes, this line equation is, what is the equation of this line? X plus, first one is 100.
Yes, sir.
Then why don't you inform me? This is 100 means this is 50, this is 100. Okay, 50, 100. So what is the value of y value 50, x value 100? Correct? Fine. This is 0 comma 50 and 100 comma 0. So this line equation is, what is the line equation here? X plus 2y is equal to 100. Right. Next one. Next line is the values x0, y0. And when x is equal to 1, in case x is equal to, for example, take x value is 20. What is the y value? 40. X value is 20, y value is 40. Here it is 20, here it is 40.
Sir, could you scroll up 1 minute?
When x is equal to 0, y is equal to 0. Actually, this is which implies it can be written as y is equal to 2x. When I give x value is 20, y value is 40. X value is 40, y value is 80. Those points you have to identify first. When it is 40, it is 80. 60, this is 1, 2. Yeah. You know, you can draw the graph directly in the exam here. No need to write x is equal to 0, y is equal to 50. For understanding purpose, I have written here. For the sake of understanding, I have written here. So we have to find the point on x-axis and y-axis. To draw the graph of the line, this line 2x minus y is equal to 0. I'm going to take, is it okay? Shall I 61, 80, 160. So like that, you can join them, all these points by a line. Okay. This is the line. which are passing through the origin. Okay, this line equation is uh, 2x minus y is equal to 0. In the same way, the last one, 2x plus y is equal to 200 here. When x is equal to 100, y is equal to 200. X is 100, y is 200. Y is 200, 0, comma 200, and save x is 100, comma 0. You can join them, these two points. Yeah. Yeah, this line is 2x plus y is equal to 200. Got it? Now coming to the inequalities, one by one. One by one, I'm going to take inequality, then I'm going to check the solution region. First one. Yeah. First one is x plus 2y is greater than 100, greater than 100. Greater than 100, nothing but what, student? Is here, is 0 comma 0 is a solution. First one, this is the line. 0 comma 0 is not a solution region, because when it's up to 0 0 here, 0 0 is 0 is not greater than 100, so it is not possible. So that the solution region of the line x plus 2y is equal to 100 is like this, part 2. Okay, this is the solution region. When you observe, see here, if you observe that the common region, already it's showing the common region, this is the common region, I think so. Accordingly, inequalities. Okay, this is first one. Coming to the second one. Second one is 2x minus y is lesser than or equal to 0. 2x minus y is lesser than or equal to 0, nothing but 2x is lesser than y, or y greater than 2x. Y greater than 2x means what is the region number? Is it right side? See, this can divide it into two parts, part 1, part 2. What is the solution region? Part 1, part 2. Y greater than 2x. Y greater than 2x. Yes?
It's part 2.
No. Part 2, right. This y greater than, see here you can take any point here, here, like part 2 is a part 2 only satisfies this y greater than 2x. You can take some x and y value, okay, then you can check it. So the required region is here, the part 2. I am going to share that part 2 region. Yeah, this part 2. Clear? Next, third one. Third equation is, third inequality is 2x plus y lesser than 200. 2x plus y lesser than 200 means when I substitute 0 0 is okay. 0 0 means 0 is lesser than 200. It is true. Means this line also having two parts, part 1, part 2. What is the solution region number? Part 1 means part 1 contain origin, part 2 is different. So part 1 is the solution because 0 comma 0 is one solution. Now when I draw the graph this, this. Below value. So what do you observe, students? What is the common region for all this? Common region for all the line. And x greater than 0, y greater than 0 means first quadrant. So this is the common region. Yeah. This shaded region is the common region. Okay, right? Here it has 4 corner points. 4 corner points. What are the 4 corner points here? First one is, what about this point, student? This point. I think 0, comma 50. Okay, this point is like 0, comma 200. But what about these 2 points? These 2 point is point of intersection of 2 lines. For example, if I take this point, let us take this is A, this is B, this is C, this is D, this point is D. We know that just C and D, we don't know A and B. Now, to solve A and B, we have to solve the equations like x plus 2y is equal to 100, you can solve. And another one is second equation, x 2x minus y. 2x minus y is equal to 0. We have to solve this. When I multiply here 2 to this equation, 2x plus 4y is equal to 200. I multiplied this equation with 2. Now, you have to solve these 2 equations. These 2 equations you can solve. So minus, 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 so get cancelled. And minus 5y is equal to minus 200. Then y is equal to, what about y value, students? 40. When y value is 40, then x value is must be 80. Y value 40 means x value is 80. Is it clear? Is it right?
It will be 20.
X will be 80, am I right? Because y is equal to 2x.
20, sir.
It will be 20, sir.
Oh, sorry, sir. Okay, okay. Right, right. That one I'm thinking here. Y value is 40, mean x corresponding x value is 20. So where I thought, okay, right. 20 comma 40. Yeah, we got one point. Then we can find the point B. Point B is the point of intersection of 2x minus y is equal to 0, as well as another line 2x plus y is equal to 200. You can solve these 2 lines. Okay, then the 2 lines are 2x minus y and 2x plus y, 200. At solving these 2 equations, when I solve this, 5y get cancelled, 4x is equal to 200, and x is equal to, what about x value? X value is 50. When x value is 50, what is y value?
100.
100, right. So 50 comma 100. The point B is 50 comma 100. So there are 4 corner points A, B, C, D. At that 4 corner points, we have to find. Okay, now you have to write the steps like the feasible region is determined by the inequalities. Like that, you have to write. After that, you can draw the graph. After draw the graph, you have to write the. Therefore, the corner points of the feasible region of the feasible feasible region, or what are the corner points? 4 corner points are there. One is 0 comma 50, 0 comma 200. First A 20 40. Now corner points. Z is the Z value. What is the Z value here in the question? X plus 2y. X plus 2y. That's it. You can draw the table. Point A is, I'm taking point A is 20 comma 40, B is 20 comma 40, 50 comma 100, 50 comma 100 or 100 comma 50. Okay. Another one is 0 comma 50, 0 comma 200. Okay, right. Substitute these values here. When it is 20, 40, what is the Z value, Amma? Is it 100? Yeah, 50 plus 200, 250. 100, 400. Yeah, see, when you observe the question here, show that minimize of Z occurs at more than 2 points. I mean, show that minimum of Z. Minimum of Z occurs at more than 2 points means like Z is maybe here, minimize, maximize. Minimize, maximize. So what about here students? What is the minimum value? Minimum is we proved here. It is the minimum values are 2 here. 100 at 2 different points. This is minimum value. Here also it is minimum. What is the maximum? There exists only one maximum. The maximum value is 400. Okay, we proved here that Z having 2 minimum values. Therefore, you have to write. Therefore, the minimum of Z is equal to 100 at, you have to write 2 points, 20 comma 40 and 0 comma 50. Maximum of Z is, the value is 400 at where? At 0 comma 200. That's it. Like that you have to write the solution. Having any doubts, students? You have
Sir,
to do.
could you explain the fourth problem one time? Like,
Sorry,
could you explain the fourth problem one time?
the fourth one.
Yeah.
You're saying you have question number 4.
Yeah.
This one.
Yeah.
Okay. First, other students, is it clear, Amma?
Yes, sir.
Fourth one. So minimize means your x plus same Kishore, like x plus 3y is equal to, you can take as 3. Same, put x is equal to 0, y value is 1, y is equal to 0, x value is 3. So here we are getting like when you take your x axis and y axis, so your x value is 3, y value is 1. 1 2, like 1 2, you can join them, will get a line. And but here it is x plus y greater than 3. When I take inequality greater than 3, when I substitute 0 comma 0 here, 0 is greater than 3 will get. Is it true? No. So here the region is, the solution region in this case, we get like this from the first inequality. Coming to second one, x plus y greater than Means x plus y here also, if you substitute 0, 0, greater than 2. If 0 is greater than 2, no. Okay, fine. First I am going to take here x plus y is equal to 2. When x is equal to 0, y value 2. Y is equal to 0, x value is 2. So nothing but 2, here 2. You can join them, these 2 points by a line. 2, 2. Now, here coming to here, it is also 0, 0 is not a solution region. For that, the solution region is part 2. This is the solution region. What is the solution region? This is the solution region. But see, student, what is the common region for this? When you see the common region x greater than 0 and y greater than 0, the common region here we are going to get in first quadrant is this region. This is the common region. This is the common region. Is it bounded, student? Is it bounded?
No.
No, it is unbounded. So this unbounded questions we don't have in the syllabus. Fourth one is unbounded question. Got it, Kishore?
Sir, then is sixth one also an unbounded question?
Yeah, sixth one also maybe. If both will be greater than or equal to, just observe that. Yeah, this is also unbounded. Unbounded questions. Sixth one also mostly will get unbounded because greater than or equal to 2 greater than. So whenever both will be lesser than, surely it is bounded. Lesser than questions. Bounded. This is bounded. This is bounded. Greater than means the region, means the area of the region is infinite. It should not be finite. We may get minimum value. We don't get maximum value of unbounded. Maximum value is infinite. At what point it is infinity, we don't know. So unbounded, we don't have in the syllabus.
But sir, for finding the minimum, we should just like substitute those 3 points.
3 points you have to substitute. In that, whatever the value will get, okay, in the question also, you have to observe that. Minimize, they are asking. Minimize, they are asking. Actually, it is unbounded question, not in the syllabus. But in case if you want to do, here we are getting 3 corner points. What are the 3 corner points here? One is, this is the corner point. Another one is point of intersection of 2 lines. Another one, this is the point. 3 points we got. You have to substitute 3 points here. You are getting 3 values. Among the 3 values, whatever the minimum, that is the minimum value of z in that unbounded region. But we should not find the maximum. Unbounded questions, surely they'll give, the question is minimize only. Minimize, only they'll give. They don't give maximize because maximum value is infinity. Okay?
Okay, sure.
Yeah, coming to the next question, word problems. Different types of word problems. There are only 3 concepts are there. Based on 3 topics, they are going to ask the question. One is manufacturing, one is diet, and one is transportation. Based on this, they are going to ask the questions. Okay. Word problem means with help of given data, we can take the objective function. We can form the inequalities. We can form the inequalities. And as it is, after forming the inequalities, after taking the objective function, same procedure will be as usual. Procedure will be same, uh, draw the lines and find the feasible region. Feasible region is given by corner points, and let us take the corner points. At that corner points, we have to find the value of z. Among that, whatever the minimum, that is the required minimum. manufacturing problems. So like, okay, coming to here, I'm going to tell you question number 1. I think question number 9 and 10, 10, 1, 9, 10, 12. Okay, 1, 9, 10. These are the unbounded questions. The rest of all bounded. The questions which is related to bounded. The question which is related to bounded. Got it, students? Question number 1 is unbounded question. Question number 9 and 10. That's all. Rest of the questions are bounded. Like, okay, let us see any question number 2 or 3, 4, something. Okay. First, let us see the question number 2 alone. One kind of the cake requires 200 grams of flour and 25 grams of fat. And another kind of cake requires 100 gram of flour and 50 gram of fat. Find the maximum number of cakes which can be made from the 5 kgs of flour, okay, and 1 kg of fat, assuming that here we have to find maximum number of cakes, and how many number of cakes and how many okay, how many number of cakes we can make with help of 5 kg of flour and 1 kg of fat, assuming that there is no shortage of the other ingredients used in making the cakes. No shortage of the other, right? Fine. With help of 5 kg flour and 1 kg fat, how many cakes can you make? This is the question. In first kind of cake requires how many grams of flour? 200 grams. 25 grams of fat. For second one, 100 grams and 50 grams. Okay. So there is 5 kgs of flour and 1 kg of fat. So how can we do this? First, actually, when we write the given data, look at here. See. Here's question number 2. Right. Here I am going to take, like, we have to form the equation in terms of x comma y. In terms of x comma y, for that, let us take here x, y. Okay. Here, there are x cakes of the first kind, y cakes of second kind. X cakes, see, two kinds of cakes are there. First kind of cake I'm taking as uh, first kind, and y is the cakes of second kind. So after taking this, here x must be, number of cakes always should be either 0 or greater than 0. Number of cakes are 0 or 1, 2, 3 like that, but it cannot be negative. Y also should be greater than or equal to 0. Nothing but we are going to get the feasible region in first quadrant alone. Okay, so I'm going to take the given information as follows, like a table. With help of table, I'm going to write. So given information can be combined in the table, for example, cakes of first kind. Next, cakes of second kind. Right, here coming to here, we are using two ingredients like flour in grams, fat in grams. Okay, in first kind, when you see the question, first kind, how many grams? 200 grams. It is clearly 200. Here it is 25. Second one is 150. Second kind and 50. So what is the availability here? So availability of flour and this. So this is in grams only. Grams we can convert it into grams. So complete availability. So how many kgs it is available? 5 kgs of flour. If we converted into grams, it will be 5,000. 5 kgs means 5,000 grams. And coming to fat is 1 kg. 1 kg means 1,000. Fine. Okay, according to this, is it difficult to write? So maximum how many kgs of 5 kgs? Maximum 5 kgs is maximum 1 kg. So it can be written as, see here, flour alone total, like in first kind of cake we are using 200 grams. Okay, in that first kind of cake, like in X, first kind of cake means X. Second kind means Y. 200 grams we are using flour uh, in first cake and 100 grams for the second kind of cake, and totally maximum number of kgs of flour is 5 kgs. It's not more. We can use maximum 5 kgs only. It should not be more than that. So that shall I write lesser than or equal to 5,000?
100 going.
100 into y. Right. Here 100 into y. In the same way, coming to fat, so 25x plus 50 grams of second kind of cake, it is lesser than or equal to 1,000. Okay, here surely x greater than or equal to 0 and y greater than or equal to 0. The number of cakes always should be positive, right? Okay, here we got, these are the two restrictions, like 1, 2, and these are the non-negative restrictions. These are the constraints. But okay, fine. How many kind of cakes are there here? Students, anyone? The total number of cakes I'm taking as Z. So first kind of cakes are X number of cakes. Second kind is Y number of cakes. Total number of cakes I'm taking as Z. Z is equal to X plus Y. Okay. The number of cakes I'm taking as Z that can be made are Z is equal to X plus Y. Okay. So as for the mathematical formulation, okay, mathematical formulation of the given problem, whether we need to find the maximum number of cake or minimum number of cakes. Here we need to
So we need
maximize,
maximum number.
we need to find the maximum number of possible cakes or only minimum. Minimum is 0. Yes. Easier we can we do maximize or minimize?
Maximum.
Maximize. We can find the maximum number of cakes with the availability 5 kgs of flour. Like this is the like a required. This is a required objective function. These are the constraints. Now, as it is procedure. Procedure is same. Like you can take as equation like a 200x plus 100y. 200x plus 100y is lesser than or equal to 500 can be written as when I cancel with two zeros, two zeros, two zeros. Then here we get 2x plus y lesser than or equal to 50. This is the equation. When I cancel with the 25, 25 ones are 25 twos are 25 40s are. Right, so that here I'm taking x plus 2y uh, lesser than or equal to 40. So actually these are the just a moment, students. Yeah, all of you try to draw the graph of this. Anna. Students, you can draw the graph of this. Okay, students. Like that, we can form the equations.